Wishing you all, I am Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today I wish to tell about crystal structures. So in the previous class, I told some brief introduction about the crystal structures. So basic information and the course overview, course objectives and course outcomes I have all discussed in the previous session. So in this session, we'll just review the previous session basic information, then we shall move to some basic definitions in this crystal structures. So in the last session, we have seen the introduction of crystal structures. In solids, according to the arrangement of atoms or molecules, solids are two types. So these are two types of solids are crystalline solids and non-crystalline solids. So in crystalline solids, again it is divided into two types, that is single crystalline solids and polycrystalline solids. So what is crystalline solids and non-crystalline solids, and how these crystalline solids can be divided into two categories, that is crystalline solids, single crystalline solids and polycrystalline solids. So in crystalline solids, the atomic structure repetition will be completely on volume based. In crystalline solids, the atomic structure repetition will be completely on volume based. So here if we take any of the crystal like this, so throughout this crystal, the atomic arrangement will be completely on volume based. So throughout the crystal, the atomic structure will be repeated. So in polycrystalline solids, coming to the polycrystalline solids, the atomic repetition, the atomic structure repetition will be up to some diameter, where in the polycrystalline solids. So in crystalline solids, atomic structure repetition will be completely on volume. If we take a cubic crystal, suppose like this, so there in this cube entirely whatever the atoms are arranged in this, they are completely in periodicity. So the atomic structure repetition will be completely on volume based in the crystalline solids, that is single crystalline solids. So where in the case of polycrystalline solids, the atomic structure repetition will be up to some diameter. Atomic structure repetition will be up to some diameter. So these are formed by small single crystallites called grains. So here in polycrystalline, so up to some diameter, the atoms are arranged. So this is totally a crystal. But in this crystal, the atomic arrangements are periodicity. It shows the periodicity of the atomic structure up to some diameter. It is having up to this area, and here we can take up to this area, and when we are taking here, so like we can say the three groups, that is three crystallites. So small single crystallites are there. So the aggregate of many small single crystals is nothing but polycrystalline solids. So that's why many small single crystal so are formed the polycrystalline solids. So atomic structure repeated up to some diameter. So the atomic structure of this single small crystal will be up to this diameter, and the second, we shall see that the atomic structure repetition will be up to here only. So these are called as grains. These are called as grains. So in non-crystalline solids, the atomic arrangement will be irregular. The atomic arrangement will be irregular. Irregular means that in randomly the atoms are arranged in the non-crystalline solids. So coming to some basic definitions, so which is very important in this module. So here we shall see that lattice or crystal lattice. Lattice or crystal lattice. So here the lattice points denote the position of atoms or molecules in the crystal. Lattice points denote the position of atoms or molecules in the crystal. So lattice is nothing but it represents the arrangement of atoms or molecules in plane or space. So lattice is representation of atomic arrangement in plane or space. So lattice means it represents arrangement of atoms or molecules in plane or space. Lattice. So first of all, lattice. What is lattice? Lattice is representation of atomic arrangement in plane or space is called the lattice. So atomic arrangement we shall see. So the atomic arrangement, so we are talking about the crystalline solids. So here in the crystalline solids, the atomic arrangement is like this. So it represents the arrangement of atoms or molecules in plane or space. That is called lattice. So these are the atoms or maybe molecules like that. So these are the atoms. So they are arranged in regular and periodic manner. They are arranged in regular and periodic manner. So So these are the lattice. So these are atomic arrangement. So this is the atomic arrangement in crystal. So the atoms are arranged in regular and periodic manner. So these atoms represented as these atomic arrangement will be represented in plane or space is called lattice. So that In every place of an atom, we are denoting or representing with a point. So for every atom is represented as a point, and all the atomic arrangement will be represented with an atoms. So these atoms are imaginary points. These atoms in the crystals can be taken imaginary points. So that imaginary points called as a lattice. So this is a lattice. Lattice represents the arrangement of atoms in plane or space. If we take a plane, so if we take like this, so the atomic arrangement is in x direction. So if we take a 2D, the atomic arrangement will be like this. So one dimensional and two dimensional. So lattice represents the arrangement of atoms of molecule or molecules in plane or space. So I'm taking a atomic arrangement in a crystal. So these are the atomic arrangement in the crystal. So for every atom, I am taking an imaginary point. For every atom, I am taking an imaginary point. So instead of this atom, there is a point. Instead of atom, there is an imaginary point like this. So this is called lattice. This is called lattice. Okay. And here each point in this lattice is called a lattice point. Each point in the lattice is called a lattice point. So lattice points denotes the position of atoms or molecules in the crystal. So every lattice point has identical with surroundings. Every lattice point has identical surroundings. If we take this lattice point, so this lattice point is identical with the surrounding lattice point. So here to here, or somewhere I can take, so here to here. This lattice point is identical with this lattice point, and this is identical with this lattice point. Like that, anywhere you can take the lattice points have identical surroundings. Suppose this can be represented with A and this can be B. Like that, they have same translational vectors. So every lattice point have identical surroundings. Coming to the plane lattice. So the lattice points arranged in a plane or two-dimensional is called plane lattice. So lattice point arranged in a two-dimensional plane, then it called as a plane lattice. So the lattice points are arranged in a plane. This is in two-dimensional. So this is two-dimensional plane. So lattice points are arranged in a plane which is in two-dimensional called as plane lattice. Called as plane lattice. Next, coming to the space lattice. Space lattice. So in this, the three-dimensional space lattice may be defined as an infinite array of points in three dimensions. An infinite array of points in three dimensions in which every point has an identical environment as any other point in the array. So suppose we can take a cube structure. So the atoms are arranged like this. So this in a 3D way the atoms are arranged. So the three-dimensional space lattice defined as an infinite array of points in three-dimensional in which every point has an identical with other lattice point in the array. So a crystal lattice refers to the geometry of a set of points in space. So crystal lattice refers to the geometry of a set of points in space. So an infinite three-dimensional array of points showing how atoms or molecules are arranged in a crystal is known as space lattice or lattice array. An infinite three-dimensional array of points showing how atoms or molecules are arranged in a crystal is known as space lattice or lattice array. So in the lattice array, every point has identical surroundings or with the environment to that of every other point in the array. Next, talk about the basis. So since lattice point is an infinitesimal point in space, a lattice point is an infinitesimal point in space. It is an imaginary concept. So lattice and lattice points are an imaginary concepts. So when each atom of crystal is replaced by a lattice point, we will have an infinite array of points. As I told previously, so here we have 4 atoms. So when we take x-axis in the y-axis, so in this way and in this way. So when each atom of a crystal is replaced by a lattice point, so this is a crystal. This is a crystal. Writing here. So this is a crystal. In this crystal, these are shows atoms. Okay, so each atom of crystal is replaced by a lattice point. So this is replaced by a lattice point here. So that is replaced by a lattice point, and here it is replaced with a point, lattice point. Here it is represented with a point, and here. So each atom of a crystal is replaced by a point. Then we have an infinite array of points in the space. So now the crystal structure is formed by associating with every lattice point a set of assembly of atoms or molecules or ions in identical composition, arrangement and orientation is called as bases. The crystal structure is formed by associating with every lattice point a set of assembly of atoms or molecules or else ions in identical composition, arrangement and orientation is called as bases. So the unit assembly indicator will be in the next slide. It will be shown in the figure. When this basis is repeated with periodicity along three-dimensional, that is x, y, z direction, we will get actual crystal. So when this basis is repeated with the periodicity ABC along x, y, z direction, then we'll get actual crystal structure. Actual crystal structure. So this is the lattice. So lattice is nothing but an imaginary concept. So when each atom in the crystal is replaced with a point, then we'll have lattice. Okay. So here every point is called in lattice. Every point is called lattice point. Okay. So here lattice is an imaginary concept plus basis a group of atoms or molecules. So combinedly we'll get the crystal structure, which is a real one, real part. So here basically basis is a group of atoms or molecules attached with each lattice point to give a real crystal. So this is real crystal, real part. This is imaginary one. So this is the group of atoms. Group of atoms or molecules. So when the basis is repeated with the periodicity ABC along XYZ directions, then we'll get actual crystal. So how the crystal structure is formed? Every lattice point a set of atoms or molecules in identical composition, arrangement and orientation is called as basis. So here in this diagram, so here we are taking a lattice. So lattice plus basis. Lattice plus basis will get the crystal structure, which is a real crystal, real part. Okay. So suppose we can take an example. So suppose if I may take that NaCl. For example, I am taking NaCl. So here the atoms are like this, points. So NaCl is a group of atoms. So here these are imaginary points, lattice points. So these are lattice points. These are lattice points. So this lattice points plus group of atoms or molecules or ions. Okay. So here we have plus NaCl. That is group of atoms. So it gives crystal structure. Okay. So here in this we are taking lattice. So lattice, we are taking lattice. So in this lattice plus group of atoms. So group of atoms like this. This is for Na and this is for Cl. This is Na. This is for Cl. Okay. So these two are associated. Lattice plus group of atoms. Lattice plus group of atoms. So each lattice point plus group of atoms comes as crystal structure. So here we can see that a real crystal may be formed like this. So lattice. So each lattice point, this one, each lattice point is this one, lattice point. So here there is a lattice point. Here also lattice point, here also lattice point, here also lattice point, and lattice point and lattice point LP. Just I'm writing in shortcut lattice point LP. So these are the lattice point. So these lattice points plus group of atoms, that is NaCl. 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 Here also NaCl. NaCl. So I think it is clear that is lattice plus group of atoms gives a real crystal, that is it forms crystal structure. It forms crystal structure. So when we take a sodium chloride cubic crystal, so here we have lattice points of the crystal. Okay, so the imaginary concept of atoms in a crystal. So here we have taken cube of so this is the lattice. So lattice, and here are lattice points. So this lattice is associated with the group of atoms. So the group of atoms is sodium and chloride. So it is formed as crystal structure like this. So here every lattice point is associated with the group of atoms. That is, here this lattice point is associated with sodium and chloride, a group of atoms. And here also this lattice point is associated with sodium and chloride atoms, group of atoms. Here and here, wherever the lattice point is there, that lattice point is associated with this group of atoms, then it forms a real crystal. So then it forms crystal structure. So that's why we can see here. So lattice point which is an imaginary one. So it is imaginary one means that atoms represented with a points. In the atoms in a crystal is represented with a points. So lattice plus basis forms real crystal, that is crystal structure. So basically, basis is a group of atoms or molecules attached with each lattice point to give a real crystal. So basis is a group of atoms or molecules attached with each lattice point to give a real crystal. So crystal structure is equals to lattice plus basis. How it can be formed as shown in the figure which I explained here. Okay, in this session we just discussed about that introduction part. Just we review, and then we saw that what is lattice and lattice points, what is plane lattice, and what is space lattice, and then we saw that basis and how the crystal structure forms. Okay, in the next session we shall continue with another topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.